Okay, the first thing that you always want to do when you start to try to factor a polynomial is to factor out the greatest common factor. That just means what do each of these terms have in common that you can take out of them. When you're factoring, it's the same thing as unmultiplying, if that makes any sense. For example, remember whenever we used to do this, we have 2 times x plus 4, and we would multiply it out. We would get 2x plus 8. Well, whenever you factor this binomial, which is also called a polynomial, it just means you're going back to this form. Your greatest common factor was 2, so you put that out front, and whatever's left over after you factor that 2 out goes on the inside. Okay, so let's have a look at A. What do these have in common? Well, first of all, the 8, the 4, and the 6 all have a 2 in common. You can factor a 2 out of that. Then you have an a squared, an a, and an a cubed. You need to try to figure out how many a's could you factor out of everything. Well, if you try to factor 3 a's out, here there's only 2, so you wouldn't be able to. If you try to factor 2 a's out, here you wouldn't be able to because there's only 1. So the most you could factor out would just be 1a. Well, how many b's could we factor out? We could only factor out 1b also. Well, when you factor a 2ab out of an 8a squared b, it just means what do you multiply by 2ab to get 8a squared b? Well, you're going to need a 4. That's how you get the 8. You're going to need another a. But do we need any more b's? We don't. 2ab times 4a is 8a squared b. So that will be our first term. Okay? Go to the next term. We're going to need a negative, and we're going to need a 2, because 2 times negative 2 is negative 4. We don't need any more a's or b's, because 2ab times negative 2 is negative 4ab. So that term is done. Then we have the last term. 2 times what is 6? Well, that'll be a 3. 8 times what is a cubed? Well, that'll be an a squared. And b times what is b cubed? Well, that would be a b squared. Multiply it back out to make sure. 2ab times 3a squared b squared is 6a cubed b cubed. So now this is completely factored. Okay, let's try B. Alright, we can probably factor out a 5 from both of these. We could also factor out a y, but can we factor out an x? This one doesn't have an x, so we actually can't. And if you wanted to, you could factor out a negative 5 to make your leading coefficient positive. It doesn't really matter though. I'll show you both ways. If you factor out a 5y from negative 30 x squared y, you'll be left with a negative 6 and an x squared, because 5y times negative 6x squared is negative 30x squared y. What about when you factor a 5y out of a 5y? You just get a 1, because 5y times 1 is 5y. So you could leave your answer in this form, or you could factor a negative 5y out. If you factored out a negative 5 here, that just means all these signs will change. You would get a 6x squared and a minus 1. Negative 5y times 6x squared is negative 30x squared y, and negative 5y times negative 1 is positive 5y. So really and truly both of these are okay. Okay, so how about C? It looks scary, but believe it or not, it's not so bad. Remember up here, we're factoring out whatever they have in common. Like here, they have the y's in common. Well, here, what do these large terms have in common? They both have all of this in common, right? So what you could do is factor all that out. Remember, whatever they have in common, you just sit it out front. Well, what do you multiply by this to get this? You multiply by 4. Well, what do you multiply by this to get this? You multiply that one by 3. Well, that's very interesting. This is going to give us a 7. 4 plus 3 is 7. So I'm just going to set it out front. But I want to show you something else. Do you notice that these two terms both have an x in them? So you could actually factor that out too. So let's go ahead and factor out the x. If you factor an x out of this one, you're left with an x, because x times x is x squared. If you factor an x out of this one, you're left with a y, because x times y is xy. Now this one is completely factored. There's actually a couple of ways you could have worked this problem. Like you could have distributed and combined like terms and then factored. Either way is fine. Okay, this software just jumped right in with some really hard problems. So what I want to do is start with that one that's in yellow first. If we want to factor by grouping, what you want to do is first make sure you're starting with 4 terms. After you do that, you should group them together in groups of 2. Sometimes you may need to rearrange the terms like we're going to do in the problems that are at the top of the page. But usually you can just go in and group the first 2, then group the last 2. Well, look at the first 2. What do they have in common? They definitely both have a 2x in common. Now, if you factor a 2x out of the first 2 terms, you're going to be left with an x plus 2. Remember, you can double check that. 2x times x is 2x squared, and 2x times 2 is 4x. Now, what you want to happen is you want to have the last set of parentheses the same exact thing as the first one. Don't automatically put it there because sometimes it won't work out. But this one, of course, is going to, because look, we already have an x plus 2. If you already have what you need, you have to factor out something. So if you have exactly what you need, just factor out a 1. If you factor out a 1, 1 times x plus 2 is still x plus 2, so it still works. Now look what you have. You have these 2 really big terms. These 2 terms have an x plus 2 in common. So what you want to do is take that out front, just like we've been doing. And if you take out this x plus 2 and this x plus 2, what are you left with? You're left with 2x plus 1. So now you have factored this polynomial with 4 terms, and you did that using factoring by grouping. Okay, so let's go back and see how we can do problems A and B. Let's start again. Now look at the first one. We know we need this to be 4 terms, which we have. We also know that we need to group them, and I want to do this in kind of a smart way. The first thing that I see is that there are some common factors which we need to factor out first. But then I see that the coefficient here is 1 and the coefficient here is 2. So over here, I know I would be factoring out some sort of a 6, either a positive or a negative 6. So that would leave this as a 2 and this as a 1. That means these 2 terms should be turned around. So let's do that first. Remember, you keep the sign that's in front of the term with the term. Go ahead and factor out that greatest common factor. In this case, it's going to be a yz. If you factor out a yz, you're left with 1 minus 2z minus 6z plus 12. That's supposed to be a cubed. Sorry about that. plus a 12z squared. Okay, now just for argument's sake, I guess you wouldn't call it that, but I'm going to put a circle around this little guy because I need to keep him here, but he'll just make everything more complicated if I drag him along the whole way. So what I want to do is just put a circle around him so I don't forget him at the end. Now I group these and I group these. Do these first two terms have anything in common? They don't, right? So we do need to factor out something. Let's go ahead and factor out that 1. Okay, now over here, I need this to look just like this one, 1 minus 2z. Well, I have a minus here where this is a plus. I have a plus here where this is a minus. So I need all these signs to change. Well, if that's supposed to happen, I need to factor out a negative. I know I can factor out a 6, and I can also factor out a z. Okay, so let's see what happens. If you factor a negative 6z out of a negative 6z, you're left with 1. If you factor a negative 6z out of a 12z squared, you're going to be left with a negative 2z. Negative 6z times negative 2z is positive 12z squared. Now what do these have in common? They both have the 1 minus 2z in common. And if you factor that out, you're left with the 1 minus 6z. Now don't forget the little guy we circled up here at the top. He still has to stay there on the outside. You have just completely factored this really big polynomial. Pretty cool, huh? Okay, so how about problem B? I wonder what color will work this time. I wonder if green will work. Let's see. Okay, if we want to factor this one, we need to do that smart business again. I think I want to put together the ones that have both A's and B's in them. Maybe that will work out? Not really sure, but let's see what happens. So for B, I'm going to have 3ab squared minus 2a squared b. And then over here, I'm going to have a minus 4a and a plus 6b. Well, let's do this smartly. If I factor these two, I would have to factor out an ab. That means I'll still have a b here. So I should put my 6b first. If you don't know what I just did, you can replay this, rewind, play again, maybe try to grasp it the next time. However, if you never do really get it, it's okay. Just keep switching them around until you find a method that works, or an order that works. Okay, let's group them. By the way, there's no greatest common factor this time, so we can go straight to grouping. We can factor out an AB from the first two. We'll be left with a 3b and a minus 2a. And the last two, we can factor out a positive 2. We'll be left with the 3b minus a 2a. Now, these both have a 3b minus 2a in common, so factor that out. And we're left with ab plus 2. The more you do, the easier it gets, so don't forget to practice.